Hi, so this is a video about writing and solving a system of equations from a word problem. Now, word problems and systems usually, not always, but usually follow a very basic format. And the very basic format basically gives you, is the two types of equations that you're going to be writing. Usually, one relates to the total value of the items, to the value of the items that you're talking about, and the other relates to the number of items you have. So one relates to number of items I have. Number of items that we have. And so here's a great example of that. We have tickets for the school play. They're $3 for students and $5 for non-students. So that's a value. On opening night, 937 tickets are sold. So that's a total number. How many tickets were sold to students and how many to non-students? All right, so if we're writing a system of linear equations, that means we're going to have two equations with two variables. So I actually have to write my let statement based on the two variables. Those let statements, the variables come directly from what's being asked because that's the unknown. We wouldn't be asking the question if it wasn't unknown, if it was known. So I'm going to let n equal number of tickets sold to non-students. And I'm going to let s equal the number of tickets to students. Okay. So then I'm going to write my two equations. So my first one, I'm going to relate to the number of items I have. So n plus s equals 937. Noticing that's the total number of items I have. I don't put anything with the n and the s. The second equation I'm going to write is going to relate to the value of those items. So I know that tickets for students were $3. For non-students were $5. And the total for students were $3, and the total amount that they collected was $39.43. So I took the value of each ticket, or the cost of each ticket, and I multiplied it by the number of tickets sold to get the total amount we collected. All right, so now we have a nice system of equations, and one suggestion is, moving systems that have big numbers around can get really tricky if you want to use substitution. So I highly recommend that you try using elimination. So if I'm going to use elimination, I want to make one of the variables the exact same number but opposite signs. So I'm going to multiply the top equation by a -3 to make the s's opposites. All right, so if I do that, I'm going to rewrite my new equation under it. I get -3n minus 3s. Oops, that doesn't look so pretty. Let me fix that. 3s equals -2,811. Okay, so now this equation I've modified. It's my new blue equation there that you see. And now with elimination, we add the equations together and one variable gets eliminated. So I can see those are going to get eliminated. We're going to get 2n equals 1,132. And then when I divide by 2, I get that n was equal to 566. So that means that 566 non-student tickets were sold. Well, if 937 total tickets were sold, then 937 minus 566, which gives me 371, is the number of tickets sold to students. All right, now what I'd suggest is on this next example, you try it and see if you're right. So see if you can set up your equations. Again, you make small wreaths and large wreaths to sell at a craft fair. Small wreaths sell for $8, large wreaths sell for $12. You think you can sell 40 total and you want to make $400. How many of each type should you bring to the fair? So if you want to try it on your own, press pause, try it, and then come on back while I do it. All right, so I'm going to let x equals small wreaths. I'm going to use x and y here. The number of small wreaths. And I'm going to let y equal the number of large wreaths. All right, so now when I do that, 1 relates to the total number of items I have, which was 40. So x plus y equals 40. And my other equation is going to relate to the value of those items. So the small ones were $8, so 8x. The large ones were 12, so 12y equals 400. Okay, now, one thing that you should always be considering when you're doing these different systems of equations, or actually any equation, is there a way for me to simplify it? Those numbers 8, 12, 400, those are kind of big. And what I noticed is they're all divisible by 4. So I decided that I actually was going to simplify the equation and divide them all by 4. And look what happens. I get 2x plus 3y equals 100. That's a little bit easier to work with. So I'm going to cross that one out so it doesn't get in my way. So now when I change the other equation, I'm going to change it to make the x's opposite. So I'm going to multiply the top equation by a -2. All right, and I'm going to rewrite it right below it. So I get -2x minus 2y equals -80. I think you can already see why this is just a nice, easy way to do it, especially if I don't have a calculator, because those numbers could have gotten a little bit bigger. All right, so the 2's are opposite, so they're going to get eliminated. 3, and I'm adding the equations together, so 3 minus 2 gives me y, so y equals 20. So that tells me really quickly that if there were 20 large wreaths sold, then there would be 20 small wreaths sold because there were 40 total. So simplifying can make these much, much easier. Okay, so we're going to look at a harder example. For whatever reason, these are called mixture problems, but mixture problems tend to give us a little bit of more of a challenge. All right, so anytime you're dealing with things that are being mixed, or you need to put solutions together, or you're mixing nuts together, or you're mixing things, I tend to use a method where we use bowls to mix things. I mix raisins and nuts in bowls, so I'm going to be mixing 2 things together to make a whole mixture. All right, so it says one solution is 80% acid, another solution is 30% acid. How much of each solution is needed, so mixed together, to make 200 liter solution that is 62% acid? All right, well, the first thing I do is I need my variables. So I'm gonna do it up here. Let x equal solution, the 80% solution amount, okay? And I'm gonna let y equal the amount of 30%. All right, so I've got my 2 amounts. Now we still relate one to the total amount we have and one to the value, but I put them in a specific location. So I put the amount on the bottom. So I know there's 200 mLs or 200 liters of the solution. So that my first equation would be x plus y equals 200. Now this is the tricky part. You actually now have to put the value, but the value has to relate in each place. So if I know it's 80% solution, I write 80% right here. And so I mix them in the bowls to get my new equation. So my new equation here would be 0.80x. I put the 30% outside here, which would be 0.30y. But these involve one more step, and this is the extra step, so pay close attention. I want it to be 62%. So I actually have to mix 62 and 200. So I have to multiply. Mix means multiply. So 0.62 times 200 gives me 124. And then what's in the bowls is your second equation. So I'm going to write it right here. 0.80x plus 0.30y equals 124. All right, well, I don't really like to work with decimals, so there's my 2 equations. So I'm going to actually clear the decimals out. I'm going to multiply by 10. Why? Because I just need to move the decimal one place to get rid of decimals. So I'm going to multiply the entire equation by 10, giving me 8x plus 3y equals 1240. I'm going to bring this one down below it because I'm always neat about that. All right. So now when I do that now, I'm going to use my new system, which is right here. I'm going to multiply the bottom of equation by a -3, and that's going to give me -3x minus 3y equals -600. All right, so this one goes away. And now I'm prepared to add these equations together. me extend the page a little bit. So that's going to give me 8x plus a negative 3x gives me 5x. The 3's are going to get eliminated, and then I get 1240 minus 600, which is 640. I divide each side by 5, and I get x equals 128. All right, so that means that x, I have 128 liters of the 80% solution, which tells me that I have, let's see, what is that, 62, or 72 of the 30% solution, because they have to add to 200. All right, hopefully that's helpful. Now on this next one, why don't you try it and then press pause and see if you got it right. A chemist has one solution that's 60% acid and another that's 30% acid. How much of each solution is needed to make a 750 ml solution that's 50% acid? Okay, so I'm going to go ahead. It's a mixture. I'm going to mix some bowls. I'm going to make some bowls. All right, so I'm going to let x equal the amount of 60% acid solution. And I really want to say the amount of, and then y is the amount of 30%. So again, total amount, x plus y equals 750. There's my one equation. My second equation, I'm going to multiply by 60%, multiply by 30%, and I want my new mix to be 50%. I'm going to multiply those for the other equation in the bowl. So 0.60x, 0.30y equals, what did I get? I got 375. All right, now I am going to be neat about this. So I'm actually going to multiply by the 10 now. So I noticed that I'm going to get rid of decimals. So I'm going to multiply by 10 in this case and rewrite it immediately. So 6x plus 3y equals, now I'm going to add that 0 to the 375, so 3750. All right, so we got a couple options. You might not have done this, but I looked and I was like, oh, they're all divisible by 3. So I chose to simplify. So I simplified this equation, divided them all by 3, which gave me 2x plus y equals 1250. And then I brought this one down. So x plus y equals 750. All right, so now there's my new system. Nice and easy. All I have to actually do is multiply the bottom or the top by a negative number, a -1. So I multiplied the negative 1 to the bottom, which made this negative, and this negative. So now I can add these equations together, and I get 2x minus x, which gives me x. The y's get eliminated, and I'm left with 500. All right, so there are 500 mLs of the 60% solution, which means there's 250 mLs of the 30% solution. All right, so that's a quick review of systems of equations, how to write them and how to solve them. Hope that helps.